Hi, everybody. So the last couple days, we've been working with solving for area of shapes like triangles, rectangles, squares, that kind of thing. Today, I'm going to ask you to solve for the area of shapes that look like this. Okay. So let's focus on problem number 1. And I want you to talk to your partner for just a minute about how you all think we might go about solving for the area of this odd shape. Take 1 minute. Okay. So as I'm listening and walking around the room, I'm hearing people say, well, do you know what kind of shape this is? Talking to their partner. And this shape altogether does not have a special name. This is no certain shape that we know of in math. But we do know that these are just two rectangles stuck together. And that's something else that I heard some of you say. Well, I'm not sure exactly what that shape is, but I do know that it's just two rectangles stuck together. And that's exactly what I was hoping you would notice about this problem. So do you all know how to find the area of a rectangle? Yeah, of course you do. That's what we've been working with. So how you might solve for the area of this odd shape is solve for the area of one piece at a time. Start with this rectangle, then do this rectangle, and then add their areas together, and that will give you the area of the shape all together. So let's go ahead and do it. Starting with this one. It is a rectangle, so we're going to use our area of a rectangle formula. Area equals length times width, where the length is 7 and the width is 3. 7 times 3 gives us an area of 21 square centimeters. Okay, now moving on to this rectangle. Let's solve for the area of it. Oh, but I'm seeing a problem. We don't have the length. We can find it though, can't we? If we know this total length is 15 and this piece is 7, then this piece must be 8 because 8 plus 7 gives you that total of 15. Now we're back in business. Here we go. Solving for the area of this rectangle. The length is 8. The width is 2. And 8 times 2 is 16. So the area of the total figure will be 21 plus 16, which equals 37 square centimeters. Now, there is one other approach to solving for the area of oddly shaped figures such as this one. I'm going to show you that second approach on this second problem, okay? So problem number 2. If we did it just like we did problem 1, then we would split it right here and we would solve for the areas and add them together, right? But I want to show you a second approach. That second approach is to fill it in as if that hole isn't there, as if it's one entire shape. Then this side would be 4 plus 3 is 7. So from here to here is 7. And from here to here is 9. So that makes it a nice whole triangle that we can find the area of. Area equals, the length is 7, the width is 9. And the area is 63 square feet. But now remember, that's the area of the entire figure as if there wasn't a hole right there, but there is a hole right there. So this isn't our answer. It's too big, isn't it? We have to subtract that hole. So we know this side length is 3. This side length must also be 3 because again, look over here. This side's 9, this side's 6. So 6 plus 3 is what makes it 9. So this is a little square right here, a 3 by 3 square. we're going to use our area of a square formula, A equals S squared. And the area of that blank space or that hole is 9 square feet. So now to find the area of this figure, just this piece right here, we're going to have to subtract 63, take away 9, which gives you 54 square feet. So the thing I love about math is there's always more than one way to solve a problem. There's always more than one way to go about solving a problem. This first approach we use is called the additive approach, where we solved specifically for those individual pieces and added the final areas together, hence the name additive approach. And this one over here is the, you guessed it, subtractive approach. We found the area of the entire figure, and then we subtracted the blank space from it. So these are both great approaches to go about solving for area of oddly shaped figures. This is actually, we're going to use the mathematical term here. This is called solving for compound area. And that's our goal today. I can solve for compound area of figures. So as you work through this, be thinking about that and let me know if you have questions.